Okay, so some questions on right. So you can't view all the chats. I can see the chats, and I will tell you what's coming. So I understand. So has anybody heard about Node.js, or what have you heard? What do you know about it? So folks here, let me know. Okay, one answer: server side JS, non-blocking IO from Gagandeep Singh, server side JavaScript again, server side scripting, great server side technology. So yeah, guys, so very smart guys around here. All of you know a lot about what Node.js. So, so I'm just going to tell what you wrote down in slightly more language. It's Node.js is a server-side JavaScript-based scripting language. The words you use, it's non-blocking, it's asynchronous, and therefore it can be used to use systems that need a lot of I/O. Okay, so uh, that's roughly what you guys said. So guys are fairly on track. So now there are 2 points came here: non-blocking and I/O, and we'll go through that. So what does the term I/O mean? We're throwing it around. What does it mean? Again, questions. Please answer. What does I/O mean to you? What is your understanding from the word I/O, or word or the term I/O? Right. So input and output. Yeah. So fairly simple question, an easy answer, but hey, smart guys, thanks. So that's correct. IO is the short form of input and output, and it essentially denotes an access done outside the main application. So outside the main. So, so all of you guys are correct again. Requests and responses. That's great. So good. So now, what are examples of IO? So in real life, can you give me examples of an IO? So I see latency, reading and writing of data, read customer data from database. That's a good one. Read write a file from Anand. DB query. That's correct. Network calls. So again, so we have a really intelligent crowd today, really smart. That's great. So yes, what examples of IO? Examples of IO include database access, access across networks, read from a file, and even two people chatting. So even that's IO. Two people chatting, you trying to book a cab on a smartphone. That's an IO. A driver responding saying, "Hey, I'll take that cab." That's an IO. People writing into floppy disks in 1990s. That was an IO. So yeah, so you got all the right network guys. Now let's talk a little more about the cost of IO. Now this is a slide that was shown in the first presentation that the inventor of Node.js made, which is essentially show the latency associated with IO. So I have a few terms here. How many? So what do you understand from the term L1 cache? How many people know what an L1 cache is or an L2 cache is? Okay, level one, level two from only that a little more better. Okay, I'll access from CPU memory. Gagadeep Singh says yes. So L1 and L2 are typically DRAM caches that are inside the microprocessor. So L1 is very close to the processor. L2 is a little further away. So as you can see, accessing data from L1 is very fast. L2 takes a little longer time. The RAM sits on the motherboard, so hey, it takes a little more time. And the disk is the hard disk on that system. So again, it takes more time in cycles. And if you're accessing data across the network that's from somewhere else, it takes a lot of time. Now, this is just a simple case. I don't know what the use case was, but this is to illustrate that as you have a lot of IO, you have a lot of the lot of latency. So when these cycles are happening, the CPU is essentially just waiting for the data to come. So there's a lot of time lost, and in our applications today, that's the case. A lot of time the CPU is just waiting for or when you have a lot of IO CPU, sometimes it is idle. So now I'm coming to Node.js. Now let's talk about usage. Now, as compared to the 1990s, do you think we have more IO or less IO? How do you think the web is progressing? So again, so everybody gets the answer. There's more, obviously. Why? Well, because when it started, the web was essentially a very passive, was supposed to be meant for passive consumption of data, like watching pictures of puppies or reading articles or reading news. That's how it started. Whereas today the web is interactive. So we use the web for chatting, for booking cabs, and for sending emails, sending short messages, and we expect the updates to be in real time. So we expect it to happen ASAP. That's a requirement today. And so now spoken. Now, why is traditional HTML? Now, there's some slightly more technical question. So So why is HTML not suited for real-time applications? Folks, any answers for that? Looking for answers. Or if you think it is, then let me know why you think it is really suited for real-time applications. It's only a structure. It's the HTTP protocol, static. So I got a few answers. It's an issue with the protocol. It is static. So I have a little image to explain that a little more in detail. Now, HTTP is a request has runs on a request response cycle. So for that, a client, so as represented here by a monitor, has to send a request to a server, and the server then looks at the request and responds with a status code and a message body. That's how it works. Now, assume if I was running a real-time chat application with HTTP, how would I have to do it? Well, the client will have to keep checking with the server. Hey, do you have updates for me? Do you have updates for me? So literally every second it'll have to keep checking. And if you want it really real time, it has to check it very often. And usually it won't have an update for it. So what happens is it turns out to be extremely inefficient. Okay. Okay. Now Node is that comes Node. So Node, I'm going to drop a few more terms here. It's asynchronous, it's event driven, it's JavaScript based, and it's essentially useful in applications that have a lot of I/O and less CPU. So if somebody was asking where is Node not useful, if you have a lot of if you have less I/O and more CPU work, so if you're just data crunching, Node is not the technology you're going to be handling with. But if you have a lot of I/O and very little processing to do for each interaction, then Node is a technology to use. So Node's extremely popular for writing WebSockets, so that open up sockets between the client and the server, so that both of them can interact in real time. So Node makes it extremely easy. There are other technologies also with which you can write. You can do it with Python. You can do it with Java. There are lots of technologies that make it possible. Uh, why is Node different? Node was written for that. So you don't have to include a specific library to make it non-blocking or to enable asynchronous or event-driven features. It is inherent in Node. It's meant for that. Okay. Any benchmarking data? I don't have any. So yeah. So Shreyas had asked, is there any benchmarking data? I don't have benchmarking data on this view right now. We can take a look at it later. Okay. So I dropped a term, asynchronous programming. Now, what does that mean? So what is this difference between synchronous and asynchronous programming? Folks, I'm looking for answers. Like Ajax, right? So Ajax is asynchronous JavaScript. So Anand says Ajax is asynchronous JavaScript. Uh, okay, I'll wait for a few more answers. So Morley says the current UI thread is blocked with synchronous. That's correct. I do have a very smart crowd today. I like talking to smart people, so and they get a lot to learn. Any more? Parallel, synchronous waits for completion, correct? So a lot of the guys already know it. So the difference between synchronous and asynchronous is that in synchronous programming, when a line is executed, only if the previous line is complete. So if it's just a long IO, if it's an IO that takes a lot of time, so it's an IO that says looking for a response is for a database across the globe, and you have a next line that is supposed to do another IO after that, completely unrelated. This the second IO will still have to wait, and typical programming languages are written that way. Only the typical programming, most programming languages, functional programmers, C, Python, PHP, are written that way. That the next line gets executed only if the previous line is completed. But for Node or JavaScript, and if you've written JavaScript, a lot of people would know it doesn't happen. If it's a time-consuming application, it can just go and execute the next line if you've written it correctly. Wow, so great. So I actually I'm getting a lot of responses, a lot of answers from a lot of people. I think I should just read out the responses from people, and they have a lot of answers. It's great. It's fantastic. Okay, so another term I dropped. I keep dropping terms. Okay, what do you understand from the term event-driven programming? That's also I said a Java that Node.js does event-driven programming. What does event-driven programming mean? Again, I'm looking for answers from my audience. What do you understand? So fire an event on click of a button. Wow, you just have the. I mean, literally wrote down the what I was going to write down when I said this. So Ashok asks, does asynchronous program means using multiple threads? Uh, so in a lot of so I'm going to answer a specific question from Ashok Bijoy Devnath. He said, does asynchronous programming means using multiple threads? That's one way of doing it. That's one way of doing it. Sometimes if you're just waiting for, so I'll give you an example of asynchronous IO. Suppose, so you could say that, hey, I'm waiting for some data, but I'm waiting for data. So at that time, this thread is not doing anything. I could do something else at that time. So asynchronous programming does not necessarily mean multiple threads. It actually does not mean multiple threads. Multiple threads means this parallel programming. So basically, okay. So event-driven programming, I had answers fire and click. When something happens, do something. That's good way of saying. So yeah. So what do you understand from event-driven programming? So it's the flow is determined by events that happen. Like as a lot of you guys said, when a client logs in, or when a mouse clicks, when there's a particular sensor output, or when there's a particular message from a program. So what happens is the main loop is listening on events, and when a particular event happens, uh, it triggers a callback. So that's how event-driven programming works. For the folks who have written JavaScript, you guys all know about it. Uh, or if the mouse gets over this icon, trigger an event, something pops out. That's an example of JavaScript. That's an example of event-driven programming. It doesn't happen all the time. If I click this button, only then does this happen. That's an example of event-driven programming you see every day. Uh, so yeah, so that's the way it happens. So there's one question from Rami Reddy Sumkura. His question is async programming. If the second line is expecting input from the first line, how will the second line execute? So in asynchronous programming, if the second line is expecting input from the first line, the second line would be called a callback function of the first line of the first function. So when you write it as a callback function, and I'll see I have a diagrammatic explanation of some that hopes to answer the question. So in event-driven programming and in asynchronous languages, it's usually implemented in callbacks. So if you want a particular function to happen only after a particular IO is complete, then you declare the function to be executed as a callback of the IO. I hope I have a slide that will show it later. Okay. Use promise, right? We can use promise. Yes, that's true. So Murli says you can use promise functions. Okay, so now this is what we call an event loop. This is a nice pictographical explanation of how Node.js's backend is working. So what happens is the Node.js, the main UI thread, it would have, say, multiple functions, multiple IO calls, and each IO call will have a callback. So a callback is the function. You say that, hey, so you would have certain functions which, certain IOs which do not depend on each other. But for if some IO, so after this IO, you say, I want this function to be called. So you would call that a callback to the function. A callback is actually sent as a variable to the function. And yeah, so this is how Node.js acts. So Node.js in its backend actually manages a pool of threads, and Node is written in such a way that it does this this thread management extremely well. Okay, guys, let me just shut down my email. Okay, okay, that's how it happens. Uh, so I'm going to let me go through an example, a particular one line of loop. Say, so for example, say task one had a function and a callback. So the Node.js, the main thread would send that function and callback to the event loop. The event loop would look at its thread pool and decide that, hey, this thread is empty, so I'll just give it to thread one. If a task two comes and say thread one is already busy, it's doing something, so I won't give it to thread. I'll give it to thread two. And so when thread one completes, it returns, and it's already been passed a call back. So here the event loop will then call the callback. Okay, so that's how the event loop works. So I'll go about it again. An example. So Node.js would have multiple IOs. If it's not an IO, it would just keep continuing on the Node.js thread. So uh, a non-IO instruction would be, say, A plus B is equal to C. That's a non-IO interaction. That just goes on the main UI thread. The uh, uh, callback, IO call would be sent to the event loop. The event loop would then look at its pool of threads and assign it to a particular thread. So it assigns the function, and it also keeps track of the callback. So for example, callback one was associated with task one. So when task one completes, it comes back to the call to the event loop, and that triggers the callback. It'll call the callback. So that's how this works. So how many threads can be configured? I actually don't know the answer to that. How does Node compare to Python Twisted or Tornado? So that's exactly what I was coming to. So the other programming languages, so Python, Ruby, they all now have asynchronous or non-blocking libraries that are used. Now, Node, why does that? Because they weren't designed for asynchronous I/O. What these developers or what the supporters of Python have done is that they've added functionality to make it possible to do async IO also. Whereas Node, it's inherent. That's what it's made for. So it does that much better than anybody else. Is there a max limit? Again, that I really don't know. I was trying to check up on that. I couldn't find. I don't know what's the max limit. I think you can configure it, but I don't know exactly how it works. Does Node.js just no yes Node.js's event loop. So Vinod asked, does Node.js manage all this? Yes, Node.js's engine manages all that. So don't all web servers work that way? Yes, it works that way. A lot of web servers work this way, but Node just makes it a lot easier. I'll put it that way. So as a lot of people asking, can I do it with Python? Can I do it PHP? You can do it. Actually, if you get time, I'll even show you a socket code written in Python, and you can see how little. And a similar code if written with Node, and you will see how tiny and how concise a node in um, in Node looks. Can't you do this Java with threads? Okay, now what's wrong with threads? So when you assign, so if you when you're working with threads, so if you could be a great engineer and great with threads, and you could do a great allocation and great management of threads, or if you're not that good, what now each thread actually consumes a certain amount of memory. It consumes a certain amount of CPU power. It's expensive. So if you're not managing your threads well, it turns out to be extremely inefficient. If you manage your threads well, yeah, cool, that's great. Now, so what Node does it for you? Node says you don't worry about the threads. I take care of it. You just keep writing your code in non-blocking and using call functions and callbacks, and I'll take care of the threads. You don't worry about it. Managing threads is my problem, and it does well. Does Node.js run off a web server? No, Node.js actually can use Node.js as a web server. We will have that in a demo. You can use Node. So Vinod asked, does Node.js run off a web server? No, you can write web servers in Node. It's so Node is a server-side language. So essentially, you can write servers in Node. How many callback functions can be used inside like one? So typically, you call. So if you okay, now you're talking about nested. So Vinayak Deshpande asks a question: how many callback functions can be used inside one another, like nested callbacks? There is actually no limit. So what you could do is that you could have a function. You could say, hey, the callback is another function which has another callback, which in case has another callback, and it actually has no limit. You can keep doing it. That is actually a word for it. It's called callback hell, because if you do a lot of it and you keep using it, it becomes very difficult to read. You're just saying, hey, okay, this is happening, this is happening. You just don't understand what is happening. So it's usually considered a bad practice to have heavily nested callback loops. So my rule of thumb is typically don't go more than two. So stop at two. Don't do more than two ever. Does managing threads? Yes. So Krishna Gade asked, is managing threads done by the event loop? Yes. The thread manages the event loop. So Vinod asked a question: is Node an HTTP independent server and can run its HTTP apps independently? Yes, Vinod, it can. It's an independent server and you can write HTTP apps on it. It's quite easy to write HTTP apps on Node. Okay, so Ajay Rao asks, how is Node.js connected to big data? Okay, so big data means big data, so a lot of data. Question is, how is this data coming today? A lot of the data is coming from a lot of devices in a lot of different places. So they're not coming from a local machine locally to you. It's coming from across places. So I'm going to talk about my example, the startup I'm doing, uh, Yatis, where we have devices embedded in a lot of cars, and so all these so these cars are far away and they're sending small amounts of data, and I don't have, but I'm going to collect a lot of this data. So from each car I'm just going to get a few kilobytes in a month. In a month, yeah, I'll get probably, yeah, kilobytes in a month. But once I aggregate the data across a lot of cars across a lot of time, it becomes big data. So you need technologies like Node.js to manage how you're getting this data in. To process the data, you'll go to Hadoop or Apache Spark, etc. But you'll use Node.js for systems that create large amounts of data. Is there any priority between the callbacks? Like if there are two callbacks, there are typically not no two callbacks. It's typically just one callback. You can nest multiple callbacks, or you can do slightly more complicated things by using an async IO, where you can create another function that calls two. So you can essentially make it as two parallel functions also. So there is no you can specify priority in a very different way. We know that it's scalable like Apache. Well, Node.js is considered to be much more scalable than Apache, much more it just goes much faster. It does not use too many threads. It scales much faster. Harish Kalyanpur asks, do you mean Node.js used to simulate loads of data? Not necessarily simulate. I'm saying just manage. As I said, right? When I put my devices on cars, I'm not simulating data, I'm getting the data. I need a system that can manage that amount of data. I don't want to have one thread to manage one device. I don't want to do that. But I want to have a socket connection that's open so that the device can talk to the server anytime and the server can talk to the device anytime. I want those kind of reactions. Now that's when Node really starts kicking ass. That's when it becomes starts becoming good. But if it's about, hey, the data is coming and I need to process the data, Node is not Node is not the technology you're looking at. And yes, I can even simulate loads of data. So one of the things we did is we could create artificial instances of cars and simulate lots of cars moving around. And we could do that also very nicely with Node. Does it have a priority based tasking? It doesn't have a priority based. If you specify a priority, it inherently doesn't. It just looks at it, and if you give it a bunch of tasks, it doesn't look at priority. It just looks at what's possible to do. It does it, and it's IO, so it just waits for. So it doesn't know so if it's doing an IO, it typically doesn't know how long it will take to get the data back. So it doesn't do anything extra. It just waits. So if you have priority, you need to specify, and there are libraries that make it very easy to do that, to do priority or to say do these in parallel, do these in series, get all the data together. There are packages that actually help you manage all that. So Ajay Rao asks, so Node.js acts as a web application server and pushes data to DB, which is then processed by Hadoop. That is yes, uh, that is a good architecture you would use. That's an architecture which, yeah, I'm also proposing that we are using. So you could use that it's used as a web application, or not necessarily web application, could be a TCP server. That's web applications is a lot more, and it would get the data and push it to a database, and then, yeah, you could run Hadoop on top of it. So Ajay, you're correct, you've got it right. Harish thanks me. Vinayak asks, can we use Node.js where IO is needed and other technology along with processing data? Yes, you can do it. So you could. So with Node, you can also you can call another process. It's a server-side language, so you can call another process. You can call it. You can make a system call through Node. So you can essentially do anything through Node. You can just declare another function. So if you want to declare a very uh, a very CPU intensive task which is done very well by Python. For example, you say, hey, the data is there, launch Python. So through Node, you can say launch Python, execute this, and you could have an event listener that's listening to the output to the log file that looks for say end of file and says, hey, it's done. You can do that. So Vinayak again asks, yeah, so for both technology and other technology in parallel, yes, so you can use two technologies in parallel. So you can run Node and Python at the same time. You can even run two different servers on one machine. You can do all that. Okay, Chemsi says he's unable to hear anything. So let me just answer him. So I have one person complaining that he can't hear anything. So I'll just answer him by I'll send him a text. Cool. So Vinod asked, he wants to ask if I can write full-fledged apps. Yes, Vinod, you can write a full-fledged HTTP app. You can create a full website. You can create a full chat server with Node. You can. And if you want, you can say that, hey, I created this web server, but I'm getting all my data. You can create a full server, and we will. I will touch upon the other libraries you'll use to create web servers, to create sockets. So okay, I'll just give you a brief. So you can use a library called Express, and with Express, you can create websites. So if you have heard of the Mean Stack, which is Mongo, Express, Angular, and Node, so that's Node is powering the entire stack, and you can write entire web applications with Node. So you can run the server, you can write the backend code, you can write the entire backend with Node, not the front end. Okay. Anand says hello. So Anand, hello. Okay. Fine. So I'm just getting to my next slide. Okay. So now this very interesting question is Node single threaded or multi threaded? This has been uh, so so folks. I kind of answered that question. Uh, so what is your interpretation? Okay. When I'm there, Ajay Rao asked a question. A web server needs to be hosted. Do you set up Node as a TCP server? So, Ajay, the correct answer is that I will create a TCP server with Node, and we will. So, if you hang around for the entire lecture, I will actually show you code in which I create a web server and an HTTP server. We will do that. We will look at it, and you can do it. So, Ajay Rao says multi-threaded. Right. So again, simple question. So the main program, the main UI thread is a single. I've answered most of this. I'll just go through it anyways. It pushes all the IO functions to the event loop, and the event loop then assigns them to a pool of threads. So short summary, the main program may run on a single thread, but the event loop manages multiple processes on multiple threads. So though when you're writing it, so for a user who's writing it, he doesn't see multiple threads, he just sees one line of code. He doesn't say launch new thread. Okay, this process launch new thread, instead another thread, doesn't do that. He just keeps writing it. As for the user, it looks like it's writing a single threaded program. With the backend, it's multi-threaded. What are the components of Node.js? It is multi-thread because the event loop maintain multiple. Yes, correct. Krishna got it right. So other question, so just informational question. Do you think Node is compiled or interpreted? Because hey, it's JavaScript based. Folks, what do you think? Interpreted, says Vinod. Okay. So actually Node is compiled. It actually gets compiled to machine code at runtime. So it's not pre-compiled and you don't have an executable. But at runtime, so just in time, it uses an engine called a Google V8 engine. Now, Google V8 engine is the engine that powers Chrome also. So a very powerful engine, it's a very smart engine, written by some extremely smart people at uh, at Google, and Node just uses Google V8. So that's one of the reasons why it's so fast. It's not interpreted; it actually gets compiled to a machine code at that point, just at runtime, and that's what makes it fast. It's an interesting trivia. So Chemsy says Node.js. Yeah, Node.js is scalable. It's so yeah. Short answer, Chemsy. No. So Chemsy asked, what about scalability of Node.js? Node.js is super scalable. I'm not going to show about how it's going to be scalable. It's not. It's just outside the scope of this lecture, but it's a super scalable language. Okay, another little trivia like question. Can I use, say, Node to access and manipulate the DOM? So can I access the browser or the browser information somehow? Folks, what do you think? Nope. Right? Murali says no. Murli says not recommended. Shreya says no. Vinod says yes. So the answer is actually no. You cannot access. You cannot access the DOM with Node. It's like PHP. You cannot read directly what is happening on the browser. You need an Ajax call made so that the browser can so that the browser sends data specifically using post or get. It's a server-side language, exactly that same format. You cannot directly access. So Node cannot get data directly from the browser. The browser needs to send it. So yeah, front-end development. So Mudurgi says that you have Angular or Sales. Yes, so you're right. So you got it right. Yeah, now this is again a little bit of my why would Node.js be a good choice for IoT applications? Okay, so I'll just jump into that. No, okay, so I'll just ask a question. So any of you guys is anybody over here who's working on any Internet of Things, any IoT applications? Anybody? Krishna is working on Arduino. Okay, that's cool. That's cool. Shreyas is waiting for an opportunity. Cool. So Sajay Rao. So there's a lot of interest. So I'm gonna touch a little upon so why I got really passionate about Node and why I decided to decide that Node is this. Why I push Node through down the throats of my organization. So Node is extremely nice if you want to write. So IoT applications are systems. They need to interact with several sensors that transmit small amounts of data. So each data that comes in doesn't have need to be processed big time. Small amounts of data. You don't want to put a separate thread to do this, but you want to have a very nice connection. So the application of nodes, it's non-blocking, it's asynchronous, it's event-driven. So with that, you can write extremely lightweight TCP app servers that can listen to a lot of these sensors. Since it's non-blocking, it can basically so a little server can access many can serve a lots of sensors, just a lot more than everybody else, lot more than if you use some of the language. And the one big reason I'm a fan of it is that since Node is written for this, you writing a socket with Node is like super easy. You don't have to start. So I saw something on Python. So you have to start importing libraries for handling multiple threads. You need to do import another function for doing async IO. So you just have to do a lot. You just use twisted and so you can do all that. It just takes much more time. The code looks a lot more funny, and you have something more less efficient. So you can get things done. People have got you have chat applications since before 2009. Node just came in 2009. So there are ways to do it. With Node, you just can do it much faster. So Krishna is sending sensor data to Google Cloud Data Store or to Cloud Data Store. And so Krishna, are you using the Google App Engine? Okay, so on Google App Engine, unfortunately, does not support Node. I've explained. So you would probably be doing it with Python or PHP or Go or something like that. But yeah, if you're using Google, you could use Compute Engine. You can write a Node application. So Vinod asked a question: if there are multiple sensors, do you need multiple server instances to interact with all of them? If you're so if there are multiple sensors to or within a limit, one node server can access a lot of them. Now, if it gets really too many, then you start need to have multiple instances of node. There is also one library from Node called Node clusters, with which you could run multiple threads of Node. So if you're running Node on a server that's multi-core, you could run multiple threads of the Node server on different cores. You can do that. Okay. So so my little bit was that it's just very it's meant for this. It's like it's saying that it's like, can I write with my left hand? Yes, I can. It's just a lot more difficult. It doesn't come out pretty. It's kind of ugly. I have to work very hard. Why? It's not. I'm a right-handed person. That's why. So I'm designed to write with my right hand. Same way. You use Node to write. If you use Node to do a lot of data crunching, it's gonna suck. So no. So you don't do it that way. You'd use Python, or you use R or SAS, or what your favorite language for doing that. But okay, so Krishna uses Python. Okay, so right, so a lot of my QA session is over. We're gonna get to slides, so a few more slides before we take a break, and then we look at some code, and then we have a QA session post that. So evolution of Node, a little bit of Node. Again, some trivia. So Node was created by Ryan Dahl. He looks like this. Apparently he's quit Node and nobody knows what he's doing nowadays. I tried to hunt up, I couldn't find anything. Apparently quit. So it's Node is sponsored by Giant. It's a company called Giant. So Giant manages Node development. Uh, so it uses the Google V8 engine, which I spoke about, the same engine that powers Google Chrome. The reason why Google Chrome seems so light and fast as compared to other browsers, Google Node uses the same engine. It's got a thriving developer community. It's got, I mean, it's like I was surprised at the kind of libraries I got for Node. So again, for my IoT application, we were sending packets on TCP on a in a very old protocol called a SLIP protocol, and I found a library that for managing SLIP protocols. uh, it's that well supported. A lot of people actually come thinking that, hey, Node is very new, you don't find much support, etc. It's completely false. There's a huge library to do a lot of things. Yesterday I found a connector to connect use Node to connect to Oracle, given by Oracle. So okay, and then so a lot of people ask this question on so what can I use with Node? So Node has a lot of third-party libs. I'm going to talk about one of them. So Express is a third-party library by which you can create web applications, like nice, cute web applications. You use and you could put Angular in front of it to manage the front end, and you have like a complete web stack. Another application kind of like is called Async. Now, async is useful if you have a lot of IO functions and you want to set up certain conditions in which how you want to access it. So you want five of them to go parallel, run in parallel, but you want three of them to go serially. And instead of using callbacks and complicated things, async IO, you can do a very nice job. So you can do things like get me data about the user from this database or from this machine, and get me data about data about Bangalore from this database, and I want to basically take both of together and put it together. You could use async IO to do an extremely good job to manage functions like that. Okay. Socket.io is another library which is used to create web sockets. So if you want to create chat servers, it's a the de facto language, right? Chat functions. There are a lot of libraries. We will touch a few more as a part of this lecture. We'll just talk about it. It's not. It's just an introductory talk. Okay. So okay, now well, I have a few cases of who will use web Node. So now here is Vladimir. He doesn't look like this, but he looks like this, let's say. And he's a full stack engineer who doesn't want to learn multiple languages for backend and front end, which is so you have to become a JavaScript expert. You have to learn HTML. That's HTML, CSS. Okay, that's given. But so sometimes, so you have front end guys who are already good at JavaScript, at it, and they have to go to the back end and say, my God, Python, or Perl, or PHP, or Java. If you know JavaScript, you can start writing Node like in no time. So that's one good reason why you would want to have Node is you don't have to learn multiple languages. So essentially, you can even reuse the same people can do a lot more. You have more flexibility. You as an engineer and even the managers who have multiple people. So that's a very nice thing about Node. And JavaScript is getting more and more popular. So, for example, if you could even use a PhoneGap to create use JavaScript to create and PhoneGap to use create even mobile apps. So you could actually say that I'm just doing JavaScript. My backend is written with Node, JavaScript based language. My front end is powered by JavaScript, some little HTML layer in there, and I can write my apps I can write my mobile apps with PhoneGap in JavaScript also. So that is, you today have an opportunity of just using JavaScript to create everything. So one cool thing. Yeah, so Vinod asked, you won't need full-blown servers like Apache anymore. You can replace them with Node. Yes, you can write a Node server. You can write a full. You don't need Apache if you're using Node. So another application, again, a little more of IoT is so Maria IoT Engineer, a lightweight system that interacts with hundreds and thousands of small sensors. I touched it, and I'll again enforce it. It's a very lightweight system, and it can create. So a TCP server is a it's not it's so a TCP connection is a lower level connection HTTP. So it's much lighter, and typically you don't need HTTP while you're working with sensors. And the other reason is that the sensors usually don't have much CPU on it, and therefore they cannot really work with HTTP also. So they have to work with a lower level language. And with Node, you can create very very easily very light small servers. So I'm writing a chat. Abdul was writing a chat application. So he wants web sockets. Now there's a nice well-developed library called socket.io by which you can write web sockets and chat applications. Like very cute. Okay. Okay, folks. This will be the last slide, and then we'll take a little break. It's 9, so we'll take a little break. So another question is it good for my employability? So it's in the valley and internationally, Node is picking up really fast. So Microsoft actively supports it. Yahoo actively uses it. Uber. So again, I became a big fan of understanding how Uber manages to find cabs so fast. So Uber actually, when you if anybody of you have used Uber, so when you demand a Uber cab, what Uber does, Uber actually finds cabs for you and then asks the driver, do you want to take this trip? And it does that, and within 15 seconds it can pull up to 3 drivers serially and tell you when it's done. That's like super fast, super fast. And it does it using Node. It's Node power empowers that infrastructure that does it that fast. It's like very cool. So friends, so extremely, there's a lot of new startups are just writing it with Node. eBay, so somebody had mentioned PayPal also uses Node. So it's an amazing list. Okay, folks. So we'll take a little break now. We'll take a 10-minute break. I will get back in time. So we'll take a. I'll also send a note. We will get back at about. We'll get back about 9:15. Okay, guys. So I'll just take a little break, and I'll be back. Hey, folks, I'm back. So, can you guys hear me? Yes, good, guys. I'm back. So yeah, so it was my little dinner break. So how many guys have taken or have had not dinner, have had not had dinner yet? Who's not had dinner yet? Question, simple question. Quite a few guys. So what's the plan? No dinner or gonna have a dinner after the meeting? Yeah, I just had a very long day. You start early usually between 5 and 6. So yeah, so quite tired. Vinayak is still in office without dinner. Saurabh says after the call, after the meeting. He has to just directly have breakfast. Oh, Chamsi's in Canada. Okay, so we have a few people from abroad. The folks from abroad. Hey guys. Jay is gonna chew on Node.js for today. Well, I hope it's I hope it's a mouthful. So right. Yeah, so I was looking at I'll just have a little more upon the slide about employability. So what I have seen is that Node actually has not hit India in full force yet. So if you go online on Google Trends, try this out. You could search on something like say Android, and you could look at geographies on with geographies searching for Android a lot, and India like comes out big time. But if you search on Node, India does not come out. It's not at the top. It's somewhere down below. So Node actually has not hit India full time yet. I think it's just waiting to come. It's happening. I was talking to a friend at SAP, and he said he's leading a team of IoT, and he says that they're actively moving to Node. So I believe that in a short time it comes well pretty well. So Chemsey, who's apparently in Canada, says that they pay very well for players in MeanStack. So MeanStack is a stack with which you develop web applications with Node. Mean is M stands for Mongo, E stands for, so you can't see what I've written. I'll just write it down. So the stack is called let's insert. Let's remove this. So mean stack. So so how many people have heard of the mean stack? So mean is M stands for Mongo, E for Express, A for Angular, N for Node. So it's a very yeah, it's a very new, a very upcoming, a very hip one, and as Gypsy says, that it's pretty popular in the Western Hemisphere already. And I'm pretty sure it's gonna hit India very soon. So it's a pretty nice set. So yeah, so that's how it is. So uh, and what's nice is that the entire, so if you choose to write on the mean stack, every part of this is JavaScript driven. So Mongo is the database, and that's also say I wouldn't say written in, but you operate it with JavaScript, a NoSQL database with JavaScript. Express, I've mentioned before, is the framework with and a routing framework for managing this, for managing web-based web application in for managing web application. Angular is a framework to manage the front end. So just the front end has its own framework, a pretty powerful one. And Node is what we're talking about is the backend, the one that powers the whole this powers the whole stack. It's a pretty cool stack, and pretty cute thing. Uh, Okay, so I'm going to talk about a little about, so we're coming towards the fag end of it. So a little bit about the course that you were hosting, and we're going to we've changed a few things now. So if you join the course, right now we have not hosted, we'll be hosting a course. So you could send emails in case you're interested, and we will get back to you. So the guys at No Big Data will get back to you on when the course will get hosted. So the course would have the first part of the course would be to understand asynchronous programming, to refresh some JavaScript concepts, event triggers, callbacks. So it's going to be similar to what we had discussions we had today. Very similar. We'll also talk about how to manage files, processes, buffers, because that so managing files, processes, buffers, that's something what JavaScript does not do because it's JavaScript is a front end language. Node is a backend language. So that's how it makes difference. Uh, is a front end line. So yeah, so that's where we started. We would then have a little course overview. So this was uh, yeah. So we'll have this. We'll show how to make HTTP servers and clients, make TCP and UDP servers, uh, and probably make a chat server. So okay, so let me just do a little clarification. So this slide was meant for a larger node course. Next node course we're going to make is going to be a smaller course targeted mostly towards making web applications. So we will cut out a few things like we won't work on the UDP, for example. We will just touch base on TCP a little, go back. Uh, then but node you can with node you can access both MySQL databases, so you can do MySQL, and you can also access Mongo, so the Mongo stack. So in the course we'll definitely do Mongo. We will cover Mongo. We will see how you use node to connect to Mongo, read into the database, write into the database. uh, okay, so Vinod's again asks how for web-based browser you need HTTP. So again, so Vinod, you can create an HTTP server with Node, and I will show you. So just wait for a while. I'll show it to you how to write an HTTP server. We would. I'll do it. I'll do it right now. So we will cover Express. We'll cover Express a lot in the course if you choose to do it. So this is to create websites. So we won't cover Angular. We won't do the mean stack. We will do the men stack. So we'll do Mongo, Express, and Node. We will that we'll cover in the course. Angular is its own little devil all by itself. That won't be covered in the course. We would also use templates. So if people have assume there are web developers here and developers here, so how many people know what templates are, or is template a completely new term for you guys? So who knows what a template is? HTML template. So anybody who's worked on Django or say what is that? A lot of so anybody who's made web applications in web applications full frameworks, they typically work with templates. We'll use EJS templates. What else will so we won't cover sockets. That was in the extended course. We won't talk about sockets. We'll take it this way. Why? So I'll just reiterate some of the things which Anjana said at the beginning. What's really different is that you'll have access to Cloud Labs, and we'll see what. So this is actually so you'll get access to your own little server on the world, and you can create your applications and let everybody on the world see it, and not have to create it on your local machine where nobody else can see it, and there's no fun in developing Node that way. It's not. It's a networking language, networking score to it. If you're not working on the cloud, it's really not it. So that's one thing that sets us aside. Uh, right. So I'm getting a few input. So a few guys who work with Django, Prabhat does. Um, okay, so that was it. Okay, the course is not over. We will do some code right now. Let me give some time. So how many people here can access? Oh, sorry, it's my bad. I wasn't in. Okay, let's get back. Okay, so the courses. So this isn't over. We will now jump into a demo site. We'll write some code. There will be a lot of questions about HTTP servers and TCP servers, and I will show. We will actually interact. But what I want is how many people can run a telnet or an NC. So the problem is that if you have a Linux laptop, it works perfectly well. The guys who don't have, if you have a Windows laptop, you may have to do some engineering right now if you have not already done it. Typically, so yes. So this is what you typically have to do if you're writing Windows. Uh, how do people? So how many guys have can run Telnet or NC from their machines? Okay, if you guys can. Okay, cool. So some people already have Windows also. Okay, so what I'll do is just so I'm going to go off screen and I'll get into say code mode now. So this is my little stack on the cloud. I'm right now, so which you guys can access it. So I'm gonna run a little server called an interaction server. So I'm gonna run node TCP interaction server. Okay, so folks, to connect to this machine, these are the commands you would use to connect to the machine. Okay, so I will keep this. So what you gotta do is, just give me a second, Control C. So what you have to do is you gotta do nc. You gotta run this on your command. So as you notice, I made a connection from this is my local host machine. And this is my machine in the cloud. So I invite guys to write to connect to me. Okay, so how to connect? You can connect via this command for the folks who can. I am sending it to all. An alternate command through telnet, send to all. Okay. Hello. So I'm getting a few connections. So hi. So I can see your IP address. Yeah. This is some machines have this problem. I have not. So this is a very light server I had written up. Let me just find the code for it. So I'm gonna go open. Was that in stop in work? How was it work? Yes, scripts, coursework. demo. So the TCP. Okay, so I can see a few guys connecting to me. I think this is a problem with some Windows machines. Some Windows machines have this issue. Uh, so what I've also done is you could, this is an interaction machine. I'm going to tell you what it means is, uh, so I had actually designed it so we could run a little survey. For example, I would ask you a question and you could say yes or no. So to say yes, you could just type yes in the machine, and if you want to say no, just say n. So a question would be for the folks who can access it. Can you have you had dinner? So the question is, have you had dinner? So I've had dinner. So I'm gonna write yes in small. Okay. So as I'm saying, I'm incrementing yes, yes, yes. Okay. And some guys have no. Now, what is the result? I want to find out what is the status of it. Okay. So to understand the status of it, I am going to go on an HTTP server. And yes, so my count, so I have 5 responses and I have 4 yeses and 1 no's. Hey, so what have I done? So I'm right now running an HTTP server also. You guys get it? So I'm running, I'm running, so as more people write yes, it's counting it. So I'm running a TCP server with which guys are interacting, which is what you can see on my screens. Okay, which is this interaction desktop. This is a TCP server. It's a TCP chat server. I'm done a networking call, and I'm also running, and I run a little survey. So I'm getting data from the TCP server, and I'm presenting that using HTTP. So folks, anybody can go do this. Okay, so you just do HTTP. So you don't have to have. So just do HTTP send to all. Just go to this. Just go to HTTP. So anybody can see this. It's an open HTTP connection where I have a server, an IP, and a port. Okay, so I can still say I can add another no and update it, and hey, no, so it got incremented. I want to say yes. It saw yes counter, updated it, and I want to see the HTTP counter. I want to see it on HTTP, and yes. Okay, so I don't know how many people have connected. I don't know. I don't know. I don't know the capacity of these servers I've created. So I'm running a TCP server and an HTTP server. Okay, and now I'm going to look at the code. So cool. So somebody write a lot of no's. Right. Cool. 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 So let's see what happened. Yes, it's all interacting. It's doing it. It's still not broken down. I hope all of you guys are accessing this on uh, on your HTTP browsers to see this. I invite you guys. I would actually like to see when my node connection breaks. So, so if it is sometimes your connections may get dropped because there are quits and etc. put in. Just log back again with telnet. Okay. So yes, no, you can go check. This count is going up. Okay, I'm going to let it run. It may crash, may not crash. I don't know what's capacity. I didn't design it for a. I did nothing to make it a high performance system. I just wrote like a basic node. Okay, now for the folks, for the nerds to see the dirty. So we're going to look into the dirty aspects of it. We're going to see what is really happening now right now. Okay, the first segment. Uh, so how many guys want to see the dirty part? Or so if you don't want to see the dirty part, actually don't have anything more. The final part of this is just a demo section. We will go through code just, and I'll try to explain what is happening. I will try to show something cool about it. What I think is cool. Others may disagree. What I think is really cool. So what am I doing in this? I'm setting up. So my basic. Okay, I'm going to open another file. So I'm opening two other files. So a basic TCP server is this. This is a basic TCP server in Node. 3 lines of code. That's it. That's it. And so what you're interacting with on my terminal right now, the guys who go to Telnet NC, the core of it is just these 3 lines. The people who are accessing the data using HTTP, this is the core of it. This is not what it is. I'll show you the data. This is the core of it. The 4 lines, you have an HTTP server running. Okay. And what I really have here, I have a TCP server and an HTTP server in the same file and with a lot of code around it. Okay. So same file, please note, same file, an HTTP server and a TCP server running. All of you guys can interact and it's not breaking. It's running on a little system. So that's how easy it is. That's how scalable it is. That's how powerful it is. Now let us understand what am I doing here. Folks, like it? Somebody's stress testing my server. Did it break? Yeah, somebody broke it. No, 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 it didn't break it. It's still alive. Yep, it's still alive. So cool. So yeah, so go ahead, break it, man. It should break somewhere. It's not designed for. So go ahead, break. So I'll just tell you a little about how this server is. So what have I set? I've set the yes counter and no counter. That's what you're seeing right now. So I create a host and a port. So I created the server. So server creation was I require. So this is like include package. So it includes package called net package, and it's creating a server. It's created a server. After creating a server, it returns a socket, and on the socket, this is what you're gonna do. So it says, so I read. So when somebody connects to it, it creates a new socket. And then it says, so this is like one thread, what some people would call a thread for one separate connection. This is not a separate thread. This is just one line of code or just one thread of code. But what will happen if whenever somebody did, so I'm going to break my connection. So I'm going to break my, or I'm not going to break my connection. I'm just going to start a new connection. Why should I break my connection? Okay, I'm just going to open a new connection. So what was that? NC, what was that? Yeah. So when I open a new connection, oh, did you break it finally? No, we didn't break it. It's just very slow now. It's not broken, it's just slow. So as you said, when I broke a connection, it created a connection and it said, hey, new connection from address so and so. And this forget that, and into the socket. So I made the connection, it says you can start writing. So it created a socket, it says write into the socket, hello, start writing. So that's what happened. When I made the connection, the server says I identify new connection and it sent me an acknowledgement. Hey, hi, you can start writing. If you want, quit. I think the quit doesn't work or something went wrong there. So, and then what I have is, so I said now, so this is again an example. So now it says when data happens. So this is an example of event driven programming. Okay. So Vinod asks, is coding style with function written as a parameter unique to Node or just your style? It is. So Vinod. So Vinod's question was he's trying to understand why you have written a function as a parameter. Vinod, that is what you do when you're using JavaScript based language. JavaScript, you do that, and that's how you do asynchronous or programming. So where you say that, where you say that create the server and then this is the and uh, pass this variable as a function, pass this function as a variable. It's a JavaScript style. It's not my style. It's a JavaScript style. And says, yeah, Java socket programming. It's true, JavaScript. So a lot of socket programming. But this is not socket. Yeah, this is socket programming. True. Great. Uh, So what am I doing here? I've done socket.on data. So this is an event. So when the event data happens, so when somebody writes into this, look at if it's quit. I think that quit is not working for some reason. I have to look at it. Uh, so when you, this is the yes counter. So when somebody writes a yes, it increments the yes counter. It also consoles logs the yes counter. So let us see how that happens. So the quit is not working for some reason, folks. I still forget not. So I decided yes. So this is what happens, yes, and it upgraded the yes counter. If I said no, it detected no and it said no counter. Okay, so that's happening here, and it console logs the address and data. It shows you this is outputting this end. Okay, uh, yeah, this was so this was when you launch the when you launch a server, you have to specify the port on which you gotta listen. So I'm using port 4001. That's why you are telnetting into an IP address and a port. That I specify that here. Okay, 4001. uh, then I have, and now in the bottom I have my HTTP server. Cool. And what is my HTTP server doing? Nothing much. It's just writing a header 200 that says "Hey, successful connection." Great, you've done a good job. You've connected. Which is all fine. That is, the content type is text, plain text, and the yes counter and the no counter. Cool. So this is what it is: the yes counter and the no counter. Now, what is why? So what have we seen here? Now we have seen a few examples of it. We have seen how to create a TCP server. We have seen how to create an HTTP server. So I created HTTP. I've created a website already. I've created a socket in which people can interact. This is the same socket in which machines can interact. So if I'm doing an IoT device, that would be the devices would be making TCP connections and talking to me. The same connection. I have not. I am. There are about 5 or 6 guys who have connected to me via TCP. I don't know how many people have connected via HTTP. Quite a few. And I'm all access to this. For me, this one line of it's one thread of code as far as I'm concerned. I'm not seeing multi-threaded code anywhere. As in the backend, something's happening there. I This is an example of event-driven programming. So when data happens, do this. Where do I see non-blocking? An example of non-blocking is I'm able to run a TCP server and an HTTP server on the same line, on the same piece of code. So it's not, so the TCP server is not blocking my HTTP server. They all, both can run in parallel. I'm not running. Please note again, I haven't included a thread package and said, please run this on this thread, run HTTP on this thread. Okay, cool. Okay, Teja Reddy says, how much time just to know if I missed too much? Yeah, Teja, this is like we are towards the far end of it. So we finished the whole lecture. We're looking at a demo, and then after this we'll have a short QA, a very short QA, and in asynchronous, how do we handle cases when response do not come for some reason? So we know the so we know that as a question in asynchronous programming. How do we handle cases when responses do not come for some reason? So we know that is the exceptions you'll have to code in to say that if it you can time out after some time, you'll have to write that in your code. So as a robust code, you'll have to write it in. I have not put that in. So typically, what you have to do for making this complete, I'll have to look at how many connections are open, are any connections dead, there if or any connections have fallen off. They've fallen off. I have to close the sockets. I have not done all that. That is when you make a nice production worthy piece of code. This is not production worthy. This is just a dirty little demo. Okay. Uh, and now what is also so okay. So this is what I was talking about. And the other thing is which I find very interesting is the variables yes counter, no counter. I'm accessing the same variables same variables across all TCP connections. So all TCP connections are able to access that variable, and even my HTTP server is able to access that server so easily. Yeah, I'm not doing any rocket science. So I could have as well as created a third HTTP server. I can create a third HTTP server, and even that could access the information. I can just keep scaling this, no problem. I can just scale it, keep scaling it upwards. Somewhere it will fall down because of it'll reach machine capacity, and it will fall down because this is not a very high end machine, and it'll fall down. Okay, cool. So any questions about this little socket? Has it fallen? It's still alive. Wow, cool. So yeah, yeah, a little novelty and kind of a demo of what you can do with it. Okay, now I'm gonna go back to some slides. Yeah, so I'll keep this socket open. I will actually run it on the background and go. So if somebody wants to run it for some more time, go ahead, play with it. This is a TCP server, as I mentioned. I started TCP server port 4001. Anyone can communicate with me. I ask yes to questions, and to see the result, you can go to port 4002. The quit doesn't work. Something's wrong. I need to look at it. We so yeah. This was a code to that I was having. So this was the things which you would have seen anyways. So again, so I'm gonna reiterate the points on this. I run the HTTP server and TCP server in the same file. They can be shared variables like yes counter. They operate concurrently. They don't block each other. I run multiple connections in the same process. As far as I'm concerned, it's the same thread also. In the background, event loop is doing something I don't care about. My data variables are shared about the connection. And as you see, the main program is running on one single thread. Now, this is possible because of the node event loop and node. Now, that's why it's kind of cool. Okay. Yeah. So those were the questions I had. This was my presentation. What I'm gonna do is I'll keep it open. Fine. It's still working. Yep, still working. Okay. Now, okay, folks. So now I've kind of finished the little slides I had, all I had to speak. We've got about 5-10 minutes. So I'm kind of open to any questions you guys have. You can shoot. We can talk about, does it synchronize on shared variables? From Jay, it's not well. It's just shared variables, not synchronizing. It just keeps updating. Both of them have access to it. I have I have written it in such a way that I've defined it outside. So it's like a global parameter for everything. You can look see it as a global parameter. So anybody and everybody can access and update it. It's like a global parameter. Intel XDK for IoT uses Node.js. Shreyas, I didn't know that. So I strongly believe, based on all I know, that all I understand is that Node.js will become more and more popular in the IoT space just because it's this easy to write. It's writing a socket. How many people are writing a socket in other languages is a little more painful. I'd call it. It's more painful. It's not as easy to do this. So if you have to, so again, so let me reiterate: Node is not a silver bullet for all your problems. If your application needs items like this, it's great. Well, you can also create great web browsers because as you see, it's extremely scalable. Uh, and the web backend is essentially the server, so you can. It's a great language to write server side code, even for the backend. Uh, Any anti-patterns? Yeah, there are a lot of patterns for using Node.js. We kind of touched, we actually spoke a little about it when somebody was talking about callbacks. So one big thing you can make Node extremely difficult to do because you can write callbacks within callbacks within callbacks, and you can create what are nested loops. Some people call it noodle code. I've heard somebody call it the boomerang code because it looks like boomerangs where you have a lot of nested loops, like and becomes very unreadable where you can't follow what is really happening. So that's one good practice. There are some people who say that. So another good practice is to not use too many uh, too many anonymous functions, which is something you can do with JavaScript also. But you can make you just because you can do a lot of things, you would end up making the node very unreadable and therefore unprocessable. Is it possible to have synchronized access on global params? Uh, Jay, I think the answer is yes. I hope I've understood it correctly. The answer is yes. Okay, folks, any more questions? A few areas where placing node will not be wise. A point from the validator for data processing. A few more applications where would I think it's not wise. Say in case in and I think of something. Well, if you have a server that's very lightly, if you just have static pages, for example, Node is overkill. For example, if you're making a website with just a bunch of static pages that doesn't have too much interaction, where people are not interacting, you just reading information off, you don't need Node. So if you're not doing much, you don't need Node. What would be your approach be to learn Node if you had to do it again? So the now question is now that's also so okay. So Teja Reddy asks me what would be my approach to learn Node if I had to do it again? How would I learn? How would I propose? So I'm going to make it a more generic question on who should learn Node. So I'll start with who should not learn Node to begin with. So if you don't know anything about programming, don't start with Node. Short. So if it's the first language we're looking at, don't start with Node. If you don't understand what clients and servers are, don't start with Node. You that basically means you don't need it, you won't appreciate it, you won't get it. I also say that if you're not very familiar with JavaScript, you if you're not familiar with JavaScript, you should brush up your Java. You should learn up some JavaScript because there are and if you don't know about event-driven programming, Node will be slightly difficult to understand. If you have done some Java, if you have done event-driven programming, and typically you do it JavaScript, that's easy to do. So I got to Node. I didn't get to it. I didn't get it directly. Okay, I did it simultaneously. I kind of got into Node, PhoneGap, and jQuery almost at the same time. And I can say that when I looked at Node for the first time, it didn't. I found it difficult. But since I was doing PhoneGap and I was writing more basic JavaScript and jQuery, it kind of made things easier. I didn't have much experience in event-driven programming before. So before yeah, till probably like 1.5 years ago, could say that. What about containers like EJB? The containers like EJB. So Vinod, can you send more So Vinod has a question. What about containers like EJB? Does Node support containers to handle other functions? So I'm trying to understand what he means by that. So if you mean by handling other processes, yes, Node can handle other processes. So other system processes it can do that. More questions? I mean, app servers, the app servers that contain that run EJB. Yeah, so an app server can run EJB or so. App server is a separate thing. The node server is a separate thing. They can interact with each other. Yes, they can access. So PID. So please share the presentation. Yes. So Rami Reddy, the we will. So Rami Reddy asked specifically to share the presentation. So the presentation and the video will be shared. Will may take a couple of days, but we will share the video and the presentation. So as we started, you don't have to take notes. You will get access to it for free. So no issues there. More question. My question is, where can we run the business logic via Node? So Vinod asks, where can you run business logic via Node and separate it as a layer? Vinod, it's you can write Node in the same file. If you want, you can write it in separate files and just include it. It's all possible. More questions, folks? Okay, then I'll call today. At the end of this, so I've got a few requests. Is which let me go back. Right. So a few requests is so you could so at the end of the webinar you would get a request to write feedback. So I would appreciate any feedback. Please let me know how I can make this lecture better. I, that's one of the things I'm trying to do. Try to so you keep listening to the people who listen to you. I want to know what went wrong, how you think I can make it better. Uh, any sort of so be frank, be clear. You could post on the No Big Data Facebook page. If you want to specifically are interested in joining courses at No Big Data, which could be Node, Mongo, or Hadoop, please just go to our webpage. If the course is not being hosted, you could send us a note. You could send them a note. They would get back to you. We'd get back to you. Uh, so yeah, that's it, folks. So thanks for your time. I hope. Yeah. So some real of course question. Okay, I have a few questions. I think I'll just finish it. Uh, some real world examples would be great. So Saurabh, I hope what I showed today was a real world example. I wrote a chat server and an HTTP server, real world examples. Uh, if you do the course, we'll do a little more detail. I can't probably also. So actually, even the Yatis webpage, it's very basic. The Yatis.in webpage, it's actually running Node. It's the UI isn't great. I just put very little time on it. We'll improve all that. It's got a lot of analytics running backend. We are actually analyzing how you're moving your mouse on the entire page and storing the data in Mongo. That all that is happening. If you go to Yatis.in, you'll not see anything of it, but it's but essentially combination of jQuery, Node, and Express and Mongo makes it extremely easy. And we actually look. So if you go there and you just look at the website, I later go and look at how did people look at the website and what's wrong with it. I know a lot of things are wrong, but so you can create websites on it. Out of course questions you have big data full day course. Karthik, you'll have to. I don't think they have one now, but you'll have to. If you set a question, I'm pretty sure Sandeep, the guy who runs it, will get back to you. I know he runs specific courses for. He did what I would call it special courses on demand. You could get back to him. Okay, a few thanks. Okay, guys, thanks for your time. It's 10 o'clock and I'm really sleepy. So, bye bye, folks. Thanks for your time.